Malaria is one of the world's most dangerous infectious diseases, affecting half of the world's population, with new drug-resistant strains emerging constantly. So, you've made it into university, and in your chem course you've been asked to make a new never-before-seen anti-malarial. You've done all the research, all the glassware is dry, everything is weighed out, it's all been added, and you've stirred it on a magnetic hot plate. Now we want to know if the reaction we just performed went to completion. For this, we use TLC, or thin layer chromatography. We spot small diluted amounts of our reactants and our final mixture on a silica plate, labeling the spots beforehand. We then immerse the plate in a solvent mixture, which moves up the plate via capillary action. As the solvent moves up, it drags the molecules in the spots upwards. Different molecules move different distances as they have different masses. Additionally, the strength of the pull on the molecules can be changed by altering the polar to non-polar solvent ratio. Under UV light, we can observe the final positions of the spots and determine whether the reaction has gone to completion. Often, the solvent ratio is not ideal, and the process must be repeated again and again until a nice result is achieved. If the reaction has gone to completion, the reaction spot or spots will not be present in the final mixture spot column. So we are now sure that we have a complete reaction and must isolate and purify the product. We do this via a process called an aqueous workup. The mixture you have made is diluted in a separating funnel with solvents that dissolve the material you're trying to isolate or form a complex with. Pressure builds up and is released at regular intervals. The system is shaken in order to allow complete mixing. After around 20 seconds of being shaken, the funnel is clamped and allowed to sit. Two layers form, a heavier organic layer and a lighter aqueous layer. You let out the lower layer and collect it. This contains what we want. The aqueous layer is kept in the funnel, and further solvent is added, and the system is again shaken, with the organic layer being let out again. This can be done multiple times and aims to extract as much of the product from the solution as possible. Next, magnesium sulfate powder is added in excess, soaking up all water and clumping together as a result. This is then poured through a cotton ball filter to remove the magnesium sulfate solid and any other insoluble contaminants. The cotton is then washed with ethanoic acetate. After all this, you are left with a near pure solution of your product. All that is left to do is dry it via a rotary evaporator. A water bath heats the solvent while pressure is lowered to encourage evaporation. Congratulations! You now have a solid sample of your product, and you are on your way to curing malaria.